Managing water efficiently is a pressing challenge in many fields like in agriculture, for crops and other industries. Water management is crucial, especially in those fields where most water is used. Imagine a scenario where you no longer need to manually control and monitor the water level and water pump used for manage. Instead, by using modern technology today, it responds intelligently to the needs of environment or any situation. By harnessing the power of a 4-bit adder, we aim to design a water pump control system that processes input from various sensors to determine when the pump should be activated. This system not only optimizes water usage but also ensures that water is delivered precisely when and where it needs, conserving resource and improving productivity. For our project development, we're using Quartus tool like software, comparing different logic gate configurations to find the most efficient solution. Ultimately, this project seeks to create an automated, reliable, and sustainable way to manage water, reducing the need for human intervention and enhancing overall efficiency. So this is our block diagram. There is 4 input and 3 output. So for the first 3, which is L, M, and H, indicate our water level, stand for low, medium, and high. The last input is indicate failure, when the main pump, which is P, our first input, cannot conduct its task. The second output is our backup pump, where it will activate when our F is 1 and H is 0. And then our last output, which is W, stand for warning if all water level is 0.
Now I will show you guys how to construct the truth table. Firstly, these 4 layers here is the input and the 3 layers here is the output. L is for low, M for medium, H for high, and F for when the P is not functioning. And then the output is pump P, BP for backup pump, and W is for warning. Warning is for when our tank is don't have any water. So yeah, how we construct the truth table? Firstly, we in the input column we need to put 00, 01, 10, 11, and the LM is 0000. After that, we do it again 00, 01, 10, 11. Yeah. But for this, we put 01, 01, 01, 01, and then so on 001, 011, and this is 10, 10, 10. And for last, we put 0001, 1011, and this is 111111. And this our output is based on the real life matter, which is one pump when the not any water in the tank, and the warning because there are no water in the tank. And then we put this one based on our real life scenario, like uh, so like this when pump is one because the tank is only medium and not full. The pump is zero only when the H is 1 or F is 1. Then the pump is 0, which means that the pump is not functioning. For the backup pump, it is 1 when the F is 1 and this and the H is 0. So like this, when the BP 1, F is 1, M is 1. But the H is 0. That's how BP is 1. Warning is only for two scenario, which is LMH is all 0. So we have only two times when the W is 1. Okay. After that, we will see for our KMap. Here is the how it looks of KMap. So we have three output P, PP, and W. So why we do KMap? Because we want to simplify the Boolean equation. So how we do it? Firstly, we need to put the one when like P right. Okay, we see the two stable. When all is what 0, P is 1. So something like this. When MHF is 0, P is 1. Okay, and so on. That P when L0 M1 H0 F0 this one. So we create this and the L0 M1 L0 F0, so the this one. So we put this. After that we will grouping it for in the two power box n. So which means that when we have something like we can group it in 2, 4 or 8 or 16, but it need to be side by side. So we do this, grouping this, and then how I get hash bar f bar, because like 000, like this up thing, 0001110 and the L 00111 or is changing, so we don't need to put L. uh, same like M 0110, so it's changing, so we don't need to put the M, but the hash F is only hash F. So what is bar? Because it's 0, so hash bar F bar D is SOP. SOP. SOP which means that it is 1. Okay. Same like BP. BP we compare it with the truth table, and then we fill in the fan map, and then we will get H bar F, because H is 0, F is 1. So H bar F is 1. So LM is don't need to type because it is changed. Cool. So for the W, we only have two value, 0000 and 0100. So we only group these two, and then we will see that 0001. So only 0 and 1 is changing. So we don't need to put the F. We only need to put the hash, L and M. So hash is bar, L is bar, M is bar, and like this is SOP. So we need to connect it with the N. Okay. Okay, this is our basic gate, and or and not gate. So but we only use the N and not basic gate because in our care map it only consist of N and not. So that's why we use N and not only. Okay, for the output P, we will have H bar and F bar. So that's why we will connect using the AND gate with the input from H and F bar. Okay, for the output BP, we will need to hash bar and F. So hash bar connect with hash bar and F only. F which is before the NOT gate, F we connect with it. Okay, and for the output W which is hash bar, L bar and M bar. Okay, W hash bar, L bar and L bar, M bar and hash bar. Okay, for the output W. This is our N basic gate. Okay. Yeah, for the next we have our non gate, but we only use NOR gate. So what happened here, which is from this basic logic gate, we transform it to this basic gate, this NOR gate. So you can see that the NOT gate is disappearing because what happened is we put bubble, one, two bubble in the back of the AND gate too, and then we pull the bubble back, and then it will collect to the NOT gate, and then the NOT and the bubble will cancel each other. That's why there is no NOT gate. And then the AND gate we have two bubble here, which is a NOR gate. So we transform it to the NOR gate, and here we don't have the NOT gate. So when the bubble is pulled back, it will transform to the NOT gate, and the NOT gate will transform into the NOR gate, which is like this, which is we to input from the F into the NOR gate, then it will become the NOT gate. Okay, so it is this NOR gate is act as AND gate, and this NOR gate act as NOT gate. Okay, you will get the same result, but it use a fewer gate. This we use 1, 2, 3, 4, 5, 6, 7, but in here we only use 4 gate. Okay. After that, we will see for the waveform. What is the function of the waveform? The function of the waveform is to know that what we want, the output is correct. So we need to know is it compatible. We need to compare it with the truth table. So we need to see the output is the same with the waveform. So for example, when the input is okay. Before that, I want to say that when the line is lower, it is 0. When the line is upper, it is 1. So continue. When the input is 0, 0, 0, 0, pump will become 1, and the W will become 1 also, but the BP will stay 0. So we compare it with the truth table. When the output is 0, 0, 0, 0, the pump is 1 and the 1 is 1. So okay, we take another example like 110, like here 1000. Pump is 1, backup pump DP is 0 and the W is 0. 1000. So we see the truth table 1000. Pump is 1, backup pump is 0, and the warning is 0. So you can check it yourself if it has any error, but I have checked it and it has any error. It is same as the truth table, same as what I want. So this project is so the output is correct lah. Okay, and this is the waveform for the AND gate, and this is the waveform for the NOR gate. So you can see that it is exactly the same because it should be the same. So if it's same, the our AND gate and our NOR gate is correct. Okay.
Creating this project feel like crafting a smart assistant for seamless water management in field and industrial setting. No more manual check. It's all automated and efficient. Using a 4-bit adder, our system smartly processes sensor data to control the pump, ensuring optimal water usage. Which quarters to light, we build and test the control logic under various conditions, exploring different setup from basic logic gates to NAND and NOR configuration. This analysis leads us to the best solution. In essence, this project goes beyond controlling a water pump. It's about creating a reliable automated system that simplifies water management, saving time and resource, and minimizing human intervention. The result offer a practical, effective approach to smart water management ready for real-world challenge.